In this video, we are going to discuss further about feedback control system and how external factor can influence the pure feedback control performance. Consider the natural draft furnace temperature control system shown on the right-hand side. The conventional feedback control system may keep the hot oil temperature close to the set point despite disturbances in oil flow rate or cold oil temperature. Temperature controller, which is TC, begin to take corrective action by adjusting the fuel gas flow based on the error from the set point. But what if there is a sudden pressure drop at fuel gas line? Actually, sudden pressure is some form of disturbance on the fuel gas line, which reduce the flow of the gas and introduce upset to the furnace operation, resulting decrease of hot oil temperature. Only after the control system detects a decrease of hot oil temperature, the temperature controller, which is TC, begin to take corrective action by adjusting the fuel gas flow based on the error from the set point, which can result in very sluggish responses to changes in fuel gas supply pressure. This disturbance is clearly associated with the manipulated variable. This disturbance effect can be overcome using cascade control system, which will be covered in separate lesson. Now we are going to sketch the control block diagram to represent the illustration on the right. From the control block diagram, temperature set point and temperature controller are programmable features in a controller. In this case, this could be a PLC. Set point is act as input command to the controller while it being compared with actual temperature monitoring, which is done via temperature transmitter, TT. To be precise, the temperature transmitter is monitoring the hot oil temperature. If the hot oil is less than the set point, TC will multiply temperature error calculated with a set of gains. This might result in increase of control variable which regulates the opening of the flow control valve. More percentage of opening of the flow control valve means more fuel will transport into the furnace, resulting more combustion in the furnace. Therefore, hot oil temperature will gradually increase. Controller normally is formed by several gain, which are proportional gain, integral gain, and derivative gain. In industries, almost 90% of the controller installed employing PID controller, whether it is electronic PID controller or more sophisticated, which is written in PLC or even DCS. It always comes in combination, which is proportional, integral, and derivative control mode as a PID controller. Now look at the plot response on the right, which is when feedback control is not used. Y slowly reaches a new steady state and has a large offset. This is also called as an open loop response. Proportional control speed up the response and reduces the offset, while additional of integral control action completely eliminate offset. Adding derivative action reduces both the peak error, which is the maximum value of y, and response time, while producing a small amount of oscillation. But bear in mind that the PID do not always result in oscillation. The closed-loop responses depend on the controller setting. In control system theory, there is several ways to determine stability of a control system. One of the methods is qualitative effect of a transient response of the closed-loop system as shown in the figure. System is stable if the root are on the left-hand side. System is not stable if the root on the right-hand side. In actual engineering application, if the oscillation has a small amplitude and damp out quickly, then the control system performance is generally considered to be satisfactory. Under certain circumstances, the oscillation may be undamped or even have amplitude that increases with time until a physical limit reached, such as control valve being fully open or completely shut. In this situation, the closed-loop system is said to be unstable. Another method to determine stability is through characteristic equation. The characteristic equation plays a decisive role in determining the system's stability. Similarly, all the roots of the characteristic equation must lie to the left of the imaginary axis in the complex plane for a stable system to exist. Okay, that's all for this time. Thank you for watching.